Okay, U1A3 has a lot less information in it than U1A2. What we're looking at here are qualitative tests. Now, most tests in chemistry are quantitative, meaning we have actual numbers assigned to them. A qualitative test, you just see evidence that doesn't have an amount attached to it, and I'm basically just going to describe what it is that you have to take a look at here. I do believe you have an assignment in the Dropbox you have to do, so you have to find an area of chemistry that uses qualitative testing and just briefly describe what happens. We're just going to go over 4 types of qualitative tests pretty quickly. You should take a quick look at some 2-3 minute YouTube videos on these just to get an idea for what they are. So a gas test. Sometimes in a reaction, what we want to do is we want to prove what's being made. So basically what we do is we mix 2 chemicals together and you'll see bubbles forming. And if you take a flaming splint and put it inside the bubbles, if it is hydrogen, it'll pop. If it's carbon dioxide, the flame will go out. If you put a glowing splint into oxygen, it will reignite. So look up your gas tests for oxygen, hydrogen, carbon dioxide. 2 and 3 go together. I'm going to describe 3 first, even though they don't do that in the content. They go 2 first. I'm going to go 3 first. If you ever took an old hose, like a garden hose, and threw it in a fire pit, what you would see is it would start to glow green. And that's because the hose has copper wiring in it. And what happens is the outer electrons in copper get energized by the fire and they jump up. When these electrons fall back down a little bit, or fall down a full level, I should say, they give off a signature color. They'll give off green. So if we take a chemical that has copper in it and we stick it into a flame, it will go green. Every chemical has a signature color that it turns. So in a sense, in chemistry, what we do if we want to identify a chemical, we burn it. Now we have sophisticated machinery that does this now called spectroscopy. So if you find some evidence at a crime site and you want to know what that evidence was made up of, they heat it up to high temperatures and they see its signature color that it gives off, or electromagnetic light that it gives off, and we can identify materials. So in a flame test, you take an unknown chemical, you stick it in a flame, you analyze the color, and you can tell what it is. Emission spectra just does this at a higher level of complexity. So you can run electrical current through it, or you can run heat through it, and you can see what the material is. Now, we can study stars through emission spectra because we can see what forms of energy the matter is giving off from those stars. So quick video, once again, short video on emission spectra. You don't need all the details. All you need to know is that we heat things up, and chemicals, because the outer electrons will jump up a level and then fall back down, and when they do, they give off energy in the form of light. That's how both flame tests and emission spectra work. Another qualitative test is a precipitation reaction. If we mix 2 chemicals together, what happens sometimes is if this is aqueous and this is aqueous, now aqueous means things dissolved in a liquid, one of these may become a solid, and that's a precipitation. So this one's a famous reaction, and we'll use this to review balancing. We have potassium iodide, or Ki. We've got lead nitrate, PbNO3, and what happens is we get a double displacement reaction. These 2 guys switch places, and we make lead iodide and potassium nitrate. Now this is aqueous. Once again, that's a salt dissolved in water. And this one here sort of floats around as chunks. This is a solid. That's a precipitate when a solid forms in an aqueous or liquid solution. Not that this is important right now, but what I want to do is I want to balance this just so we can see another example of balancing as we go through. We've got 2 I's there. So I have 2 I's here. I have 2 K's here. So I have 2 K's here. I always balance these things in brackets as though they're one thing. So I have 2 of the NO3. So I imagine the NO3 is one thing. I have 2 NO3s here, and I have 2 NO3s here. So this is now balanced. This is a precipitation reaction. They're going to become more important later in the course, and I'm going to try and guide you towards a sheet that will help you with these precipitation reactions as we go on. For now, all you have to understand is that in chemistry, we have quantitative ways of testing things where we actually get full numbers to try and describe things. And we have qualitative ways, where qualitative, you just look at the evidence. You don't actually measure the evidence.